last unit for gas laws, and we're going to talk about it very quick. It should be a very quick lesson, and that is effusion and diffusion. Okay, so these are two examples of effusion and diffusion, and let's go on and talk about them. So diffusion is the gradual mixing of two gases due to their spontaneous random nature. So the fact that we're in a room and we've got gas particles moving all around us, if we are to release other gas particles throughout the room, eventually you would smell it throughout the whole room. That's why we can smell perfume when someone sprays it across the room, or air fresheners, or let's say burnt popcorn. We can smell that. For someone burns popcorn down in the microwave, we can smell it 2 or 3 classrooms away, and that's because of diffusion, because it's random mixing of the particles. Okay, now diffusion happens quickly because the gas particles are moving so rapidly. Diffusion happens in liquids too, but it's much slower because their gas particles aren't moving as quickly. Effusion is the process by where molecules will escape out of a container through a tiny opening in the container. So it might take a while for them to all escape, but eventually, because of the random motion, like they're showing here, they would come out. Okay. An example of effusion that we're used to is helium will effuse out the tiny little openings in air balloons faster than air because of the helium's lighter. Also, let's say we have a flat tire, we've got a little hole, eventually the tire goes flat because the particles escape out that hole. So the rates of diffusion and effusion are going to depend on the velocity of the particles and the mass, okay? And it makes complete and perfect sense that lighter mass particles will effuse or diffuse faster. Which brings us to Graham's law, okay? And it states that the rate of effusion of gases at the same temperature and pressure are inversely proportional to the square roots of their molar masses. So what does that look like? It looks like this. If I have rate A of gas A over rate of B, it's going to be equal to the square root of molar mass of B over the square root of the molar mass of A. Okay, so they're inversely proportional. Okay, so let's do a couple of examples and then we're done with this lesson. I told you to be fast. Oops, I don't know why we have 2 slides on there, but we do. All right, so this first example says compare the rates of effusion of ammonia, which is NH3, and hydrochloric acid, which is HCl, at the same temperature and pressure. It wants to know how much faster does ammonia effuse than HCl. Okay, so first thing we're going to need to do is get the molar mass of both gases. Okay, so we're going to get the molar mass of both gases. Quickly add that up in your calculator if you want. Molar mass of NH3 is 17.04 grams per mole, and the molar mass of HCl is 36.46. Okay, so rate of NH3 over rate of HCl, because we're comparing them. So it's going to be square root of the molar mass of 36.46 over, I can just do the whole thing, square root of 17.04. And when we do that math, we get 1.463. So basically what that means is NH3 moves or diffuses or effuses about almost 1.5 times faster. So we'll say about 1.5 times faster. It's a little bit less, but we'll just call it a day with 1.5. Okay? So that's how you do that. But what if they give you this one? This one is telling us that nitrogen gas fuses through a pinhole 1.7 times faster than another unknown gaseous element. So you could kind of almost use this to kind of figure out what an element is if you knew it was an elemental gas. In this case, it's elemental, so we'll be able to figure out what the molar mass is and compare it to an elemental gas on the periodic table. Okay, so we're going to have rate of nitrogen, over, we'll call it rate of X, because we don't know what it is. It's going to be equal to the square root of the molar mass of X over the molar mass of nitrogen, which is 28.02. So nitrogen equals 28.02 molar mass, grams per mole. And that's equal to 1.7. Okay, so good old-fashioned math here. First thing we need to do is get rid of that square root sign so that we can get to it. So I'm going to change colors so we can see that we're doing a different step. So when we get rid of that, we're going to square both sides. I wrote really big. I should have written smaller. And so when we do that, we're going to have X over 28.02 equals 2.9 after I square that. And of course now it's just about solving for X. Okay, so X is now going to be equal to 2.9 times 28.02, which is going to be equal to 81.25, whoops, 0.258. And of course this is grams per mole because we're talking about molar masses here. And so if I go look at the periodic table, the closest elemental gas that's going to be to that number is in fact krypton. And so we could say that is krypton. Okay, so that's going to end this unit. So that means we're going to have a test coming up soon. So when you study, make sure you study the notes, make sure you study all the worksheets, and make sure you do your left side activities. All right.